Welcome to the video for Atomic Structure 1.1 Fundamental Particles. You need to look at your textbook, it's on pages 4 to 5. And before we start, just need to mention that although I've said it's for 1.1 Fundamental Particles, I have included some information about the structure of the atom from 1.3, which is about electrons, because it makes sense to have all the stuff together about the structure of the atom. So lesson objectives for this lesson are to appreciate that there are various models to illustrate atomic structure, to be able to describe the structure of atoms in terms of protons, neutrons and electrons, and recall the relative mass and relative charge of protons, neutrons and electrons. The first thing we need to talk about is the history of the atom. So going from something quite basic on the left-hand side, which is just blocks and cubes, to the modern idea represented by the right-hand side. So the first people to discuss the atom was in 400 BC, where some Greek philosophers proposed that matter is made up of indivisible building blocks, and they called these atomos, because atomos in Greek means indivisible, so there's this idea that there were building blocks that couldn't be made any smaller. So after the ancient Greeks, in 1661, Robert Boyle came along, and he proposed the idea of elements which couldn't be made simpler. So he was the first person to propose the idea that in an element, atoms would all be identical. So if you had gold, for example, which is an element, that every single atom of those would be identical. So the next important person was in 1803, which was John Dalton, and he came up with the idea that atoms cannot be broken down, so they're unbreakable, and that all atoms of an element would have the same mass. So he's expanding on what Boyle said, and that furthermore, if you had atoms of different elements, that they would have different masses. The next important person was in 1896, and that was Henry Becquerel, and he discovered radioactivity. And when he discovered radioactivity, he came up with the idea that what radioactivity was, which was that that the atom was breaking down and particles were coming out of it. So this showed that there was particles coming out from inside the atom. So it went against this idea that the atom couldn't be broken down and was the smallest part of something. So he came up with the idea of these subatomic particles, so particles smaller than the atom, and therefore this idea that the atom is not indivisible. The next important person was in 1897, and this was J.J. Thomson. Now he discovered the electron, and he identified that the electron was negatively charged. And because he knew that the electron was negatively charged, he suggested what's called the plum pudding model. So on the left-hand side there's an illustration of a plum pudding from cookery, which is where you've got the cake, and then inside the cake, spread throughout the cake, you've got plums. So his idea was that the atom was positive charge, and then throughout this positive charge we had the electrons, which were negatively charged, scattered throughout it, much like the plums in plum pudding. So this theory was discounted in 1911 by Ernest Rutherford, who discovered that there was a mass and positive charge in the middle of an atom, so that all the mass and all the positive charge would concentrate in this tiny nucleus in the middle of the atom, and that most of the atom was empty space, and that the electrons then circulated around the nucleus. And he discovered this from a very famous gold foil experiment, which you should look in details upon. So the next important person was in 1913, which was Niels Bohr, and he came up with this solar system model. So in our solar system, which is represented on the bottom right of this slide, you've got the sun in the middle, and then the planets revolve around the sun. So his idea was that you had this positive mass in the middle, which was the nucleus, and then the electrons orbited around it, but they had distinct places, so much like our planets can only be in distinct orbits. But he had this idea that the electrons had to be in distinct orbits around the positive nucleus. Now, there's a bit of a mistake on this slide in that it's got a neutron on it, and actually at this point when Niels Bohr came up with his theory, neutrons hadn't yet been discovered. So his idea was really ignoring the neutron there, that you had protons in the middle and the electrons going around outside it. And this was the start of something called quantum theory. So it starts to get a bit complicated. So in 1926, there was a scientist called Erwin Schrödinger, And he came up with this big horrible equation, which I've put on the slide there. You don't need to worry about it at all. It's horrible and complicated, and it gives nightmares to lots of chemistry degree students and physics degree students. I still have flashbacks on it. So you don't need to worry about the equation, but that's what he was very famous for, that equation. And also, more commonly for non-scientists, a lot of non-scientists will have heard of Schrödinger because of his cat. So Schrödinger came up with this idea that an electron behaved both as a wave and as a particle, and this was the birth of quantum mechanics, which is really horrible and complicated, and you don't need to understand the details of it. So in 1932, James Chadwick discovered the neutron. So then we could come up with this modern idea where you've got the proton and neutron in the nucleus, and then the electrons orbit around it in distinct orbitals. So around about this idea, just afterwards, there was also, although it wasn't to do with the structure of the atom, a scientist called Gilbert Lewis came up with this really important idea that noble gases were inert due to their fallout shell, and that ions were formed by atoms gaining or losing electrons, and that also atoms could bond by sharing electrons. So this is very important for bonding later in AS level, and something that you would have come across at GCSE. So that was the history of atomic structure and how the ideas developed. So the modern idea of what an atom looks like, really what your exam board wants you to describe it at, is shown here. So you've got protons and neutrons in the middle of the nucleus, and then electrons orbiting around it. You need to know the properties of subatomic particles. So you've got a proton, a neutron, an electron, and you need to know their relative masses and relative charges. So the relative mass of a proton is 1, the relative mass of a neutron is 1, and the relative mass of an electron is 1 divided by 1840. And the relative charges, a proton has +1, a neutron has 0 charge, hence from the name neutral, and an electron has a charge of -1. So you need to learn this table and know it off by heart. So just a few extra notes before we finish. You sometimes hear protons and neutrons described as nucleons, and their subatomic particles are found in the nucleus. So an electron is not a nucleon because it's not found in the nucleus. The force of attraction between the electrons and the protons is known as an electrostatic force because it's between a positive and a minus. And sometimes when students or scientists look at the atom, it doesn't make sense because you've got all this positive charge located in the middle as a big clump. And you might expect the protons to repel each other because they're all positively charged. And they will in fact repel each other, however, they're held together by something called a strong nuclear force. Now, you don't need to know about this at A level, but it just helps you understand why if you don't understand that there is this strong nuclear force, then it doesn't make sense why the positives are together. And the other important point is that in that previous table we used relative masses. If we used absolute masses, say in grams, the numbers would be horrendously small, and we'd have to use standard form. So instead we use relative masses and charges to describe subatomic particles, because the numbers are really, really small otherwise. So back to our lesson objectives, which were to appreciate that there's various models that illustrate atomic structure, describe the structure of atoms in terms of protons, neutrons, and electrons, and recall the relative mass and relative charges of protons, neutrons, and electrons. So if you don't understand it, go back and watch the video, look at textbooks, do whatever you have to do to make sure you understand that. Now, if you're watching the Office Mix version of this, then there's a quiz on the following slides, and there's also a simulator where you can build an atom and play. There's 4 different games for you to play, so don't forget to do that.